Welcome back. In the previous video we looked at how to model the box folding problem, and we found that we could find the volume of the box using this formula, and we knew the domain had to be between 0 and 2.5. Now we switched over to Desmos, and there we go. And in Desmos, let me zoom it back out a little bit, we saw that you got a max just before 1, and that with that max the height was about 15. But we weren't sure exactly where it was. We knew it was a little bit before 1, maybe between 0.9 and 1, but we'd like an exact value. Alright, so let's head back over and work it out using some calculus. So we know that the max values are going to occur when the derivative of the volume is equal to 0. So let's find the derivative of v. Well, okay, we have this product of 3 linear factors, so maybe it would be nice to actually know what that product was. So let's see, if we work out the, we just distribute this out, let's see, we get 4x cubed, and then we're going to get minus 24x squared and plus 35x. Okay, so the derivative of that is pretty easy. We'll get 12x squared minus 48x plus 35. All right, so that's the derivative, but we want to know, when does the derivative equal 0? Since this is a quadratic, we could immediately plug this into the quadratic formula. Fine. We do that, we get x is equal to 48 plus or minus the square root of, let's see, 48 squared is 2304, minus 4 times 35 times 12. So 4 times 35 is 140, times 12 is 1680, and then we divide by twice 12, which is 24. All right, so we'll simplify a little bit. 48 plus minus, let's see, the difference is going to be, let's see, 624, so root 624 over 24. And now 624, that is equal to 16 times 39, so this will be 4 root 39 over 24. And if we break this up into two fractions, 48 over 24 is 2, plus or minus, okay, 4 over 24 will be 1 over 6, so root 39 over 6. All right, now let's make sure this makes some sense. So first, root 39 is about 6. It's a little bigger than 6. So if you divided it by 6, you'd get something which is about 1. It's going to be a little bigger than 1. All right, so we had two possibilities for x. You could have 2 plus something about 1, which would put you about 3. But remember our domain. Our domain up here stopped at 2.5. So of the two options, well, one of them we have to toss out. So 2 plus root 39 over 6, that is not going to work because that is not in the domain. It's too big. Right? This is greater than 3. Okay, so the other option is going to be 2 minus root 39 over 6. And that, well, let's see, root 39 over 6, we said that was a little bigger than 1. So 2 minus root 39 over 6 will be about 1, but a little smaller than 1. And that's what the graph actually suggested was the correct answer anyway. We knew it was going to be some number just a little bit smaller than 1. And so in fact, the x value that will maximize our volume is 2 minus root 39 over 6. Okay. If I wanted to actually know what that volume was, well, I could take my volume formula and apply it to 2 minus root 39 over 6. So that means I'd actually shove that x value back into our volume formula up here.